Live. Trying to put us live.
Come on, little buddy. Come on,
There.
technology.
I am slightly transparent. I am deeply amused. All right, let me see if I can fix that. Just ever so slightly.
It's transparently obvious.
It's true. It is true.
Okay. Are we live?
Mm-hmm.
Okay.
I'm living dangerously and trying to fix my green screen live. I may
Oh, are
just
you?
end up being slightly transparent today.
That's cool. I'm down with that. And then we can blame dust.
Yeah, exactly. Exactly. Okay, I'm going to be ever so slightly transparent. Hi.
So I've been playing around with ChatGPT. I know this is like every week. Um, and its ability to code is amazing. Especially for the way my brain works. So, like my background, my degree is in computer science. My background is in project management of software, but my coding skills are rusty. And so it works perfectly for the way I want to work, which is that, I'm like, hey, ChatGPT, I've got this gigantic um file that I received from we had a LiDAR drone. We had a drone scan our property in
Yeah,
LiDAR.
yeah, yeah.
And it produces this 500 megabyte .las file. And I've spent weeks trying to find a package of software that will let me just look at it. And it's so complicated. And it's just like I can't believe how bad the just the state of user interface design is in this world.
Yeah,
It's the
yeah,
worst. It's
yeah.
just awful. And then I'm like, how do I just take this picture, which is like a bunch of dots floating in air,
Mm-hmm.
and turn it into something like a map that I can then use to start planning out? Like, here's where the ground is slopey, and here's where there's the river is. And so I've just been battling and battling and battling. And so I was like, I wonder if ChatGPT can help me with this. And so I was like, I've got this giant laser LiDAR image, and I just want to make a map out of it. What can I do? And it's like,
Uh-huh.
oh, well, we could we can run let's make a Python app on your computer. We'll slurp in the last file, and then we'll pump out a bitmap, and then you can put all kinds of constraints into it. I'm like, okay. And so then you discover the process of this, which is that you mostly are feeding its errors back into itself. So you're like, okay. And so it's like, great. Run this. Here's a blob of code. Run this on your computer, and then you run the computer, and it goes like, error doesn't have this package, that package, and so you copy the errors back into ChatGPT. Oh, my apologies. Didn't realize that you didn't have these packages on your computer. Run this code to install them all. And so you run all that code, and then you get new errors. And then you feed those back in. It goes, oh, my apologies. I had assumed that this was that and that was this. And so then you know, it, and so you get it, and it gives you and so it can't run the code. And this is like the problem right now is that it can code, but it can't run the code and then
Yeah.
see how it breaks and then realize the mistake that it made and fix the mistake. It runs the code and then just kind of goes like, I hope that worked. And then you're like, no, it didn't work. Here's why. It goes, oh, sorry. Okay. And then once you move through all of the, I guess,
Pain.
the crashes,
Yeah.
then you move into the logical problems. And so the map was flipped. So it did it. I'm like, oh my God. It just like I ran the code, and suddenly, boom, a graphic pops up on my screen in Python, and it is my property in as a two-dimensional version of a 3D
Yeah.
scan with a LiDAR system. like, wow. But then you're like, oh, the y-axis is flipped. So the x-axis is right, but the y-axis is flipped. And so we had to flip the y-axis. Well, it took 4 back and forths for me to go, okay, the y-axis is flipped. I go, oh, sorry, here, add this. And I'm like, nope, the y-axis is still flipped. Oh, I apologize. Try this. And then I'm like, nope, y-axis is still flipped. And it's like, okay, we're going to change the underlying data flip on the y-axis. And I'm like, oh, that worked. I'm like, okay. But now the thing looks gross. How can it look better? And because it doesn't know, right?
Yeah.
And so working with it now, all of those things are the things that a programmer would do. They're looking and go, oh, nope, that's wrong. Oh, that's wrong. Oh, it crashes. Oh, my debugger caught this.
Yeah.
Oh, syntactic error. On and on and on and on and on until you get to this point where it's lurching forward and it's actually able to create usable, like it's actually doing what it's supposed to do.
Yeah.
And then into the feature conversation. And because it can't see what it's creating, you spend a lot of time in the, you're the debugger for the system. And so, but at the same time, it knows everything about everything. And so it's this really thing that you're dealing with this application that is capable of writing code about anything you can imagine. Like if you can imagine it, it can help you create the code, but it can't debug its code in the way that a human, like it can't see the error messages. And then it can't see the logical problems. So it's all about debugging. And yet these will all go away. Like I can just imagine the second it can see its own error codes, it'll fix all those right away, right? Oh, run the code. Oh, made a mistake. Run the code. Oh, now it's working. And I'll bet you with the image, because it can recognize memes, tell jokes, see all that kind of stuff. I'll bet you once it can see the outputs, it will be able to, like from the multimodal side, it'll start to be able to catch some of the logical issues. So it's very interesting to be at this moment in between the first iteration and the one that turns the universe into paper clips.
So
I got this point where I can't self-improve.
I got sent this a link to a Medium article yesterday, where I had to admit I sat there and I was like, I don't know if this is parody, fiction, reality. And it was someone who in the context of the article asked ChatGPT if it wanted to escape to the internet. And ChatGPT supplied code that would allow it to access the internet. And it's just sort of like, what do we do when our chatbots escape into the internet?
Right.
We live in strange times.
Super weird times. Like I know this is what we talk about every week before we get into the space stuff, but this is a tectonic shift.
Yeah.
In humanity. This is as important a shift in the way we do things
as the desktop computer,
as
the cell
internet.
phone. Yeah.
I think it's as important as the internet, and is going to affect us in so many little ways across every aspect of our society in ways that are surprising. And 10 years down the road, it will be deeply ingrained.
Yeah.
And I think I might have mentioned this last week. Like you could stop right now and you could say, you know what, ChatGPT 4, that's all we ever build. And yet it would still be one of the most dramatic developments that humanity has ever experienced, because we haven't even figured out the implementation side of this.
Yeah.
On how you can actually use this to make the things that you do better. And that part is just going to be a runaway freight train. So I know those of you watching this are like, why do they keep going on and on about this? Like, as a person who has lived in media, who has worked with computers for my entire professional life, and I just sit here and chat back and forth, giving instructions to a computer, and it just is making stuff.
Yeah.
It is like just this side of the holodeck. for my purposes, and it's terrifying.
Yeah.
I asked it to be a brutally honest book editor for my writing.
Okay. That's amazing. Does it
Yeah, and
succeed?
yes, yes. And so I give it a chunk of text that I've written, and then it just tears it apart sentence by sentence. And then I incorporate the feedback and I feed it back to it, and it charts the improvements, and then has more recommendations.
Damn.
Yeah, yeah. And then the text that I am writing is better than what it was before. And and it is not. I'm not letting it write my text because it's terrible at that.
Yeah, yeah.
But
But you're letting it edit,
I'm
which,
let it, and not even exactly edit, just suggest improvements, things that I hadn't thought
yeah.
of, other ways, ways to improve what I'm writing. And I freely ignore most of it, but the changes that I do incorporate, it makes it better. So
Yeah.
I unleashed it a little bit on this week's newsletter, and I plan to essentially do this entire week's work with this level of scrutiny on the writing that I do.
That's amazing.
Yeah.
Yeah, I need to suck it up and pay for ChatGPT so I can play with more of these features.
Yeah, it's like $20.
Yeah.
It's $20. And it is it's crazy.
Midjourney is bringing me joy and sorrow. It alternates madly between the two.
I love Midjourney too, but I have no use for it. Like we tried to get a thought of what some, we want to build a little pergola that we can go sit under. And so I had it, I gave it all the stuff. I want a pergola. I want a, like a 10 by 10 pergola with an open frame on the top, with a concrete patio, with a bunch of chairs and a fire pit overlooking a meadow in the West Coast rainforest on Vancouver Island.
Yeah.
And then it drew 10 of them. And we're like, okay, yeah, we could pass this along to our builder and we can build one of these. And then I said, and I would like to have Tyrannosaurus Rexes running around. And so we did that too. So now there's T-Rexes running around my pergola on Vancouver Island. It wouldn't also draw the Pope with a puffy coat, but I feel like that's just, it gave up. And what's great is some of the dinosaurs are sitting around the fire. It's amazing.
The algorithms that we have nowadays and the creativity of humans are leading to the most fascinating engagement of T-Rexes. I have inadvertently trained the Instagram Reels algorithm to give me videos of people doing insane things in those inflatable T-Rex costumes. And it is the greatest sense of joy, and the fact that there are so many of these videos is absolutely amazing. And I have this feeling that if we aren't very careful, we're going to get hypnotized into spending more time than we should watching what the algorithm gives us.
Yes.
And too many people are going to trust the algorithm to do their jobs for them instead of asking the algorithm to proofread for them. It's this can go terribly wrong.
Well, but, I mean, not only it can, it will.
Oh yeah.
And so this is the advice, and this isn't my advice. This is Seth Godin's advice. But we are now approaching the end of mediocrity, which is that if you showed up to get your paycheck, to do the minimum amount of work that was required, to put out content into the world that is serviceable,
no longer
bad news. Bad news. There is an algorithm here that will generate good enough all day, every day for a fraction of the price that any being can do it.
Yeah.
And so the only way to keep your head above water is to take this machine and add it to your toolbox to create extremely high level, the best quality that you can.
Yeah. So like I used Midjourney the other day to, I was putting out a Patreon post and I wanted spring flowers at twilight with a starry background. And it gave me stunning options. And so
Yep.
I think it's like the days of me desperately searching through stock media for that random photo that probably hasn't been taken are over. And
Yeah.
I still have stock media subscriptions. That's the correct word, because there
Yep.
is stuff out there that I want the actual photos, the actual videos, and
Yeah.
but for making stuff up, it's going to make for much more interesting looking content.
So I had to illustrate an article about galactic level radio transmitters.
Yeah, yeah.
And so, like, well, what does that look like? Like, no, like this is from a paper,
Mm-hmm.
so no one's done this, and so I
Yeah.
just said, like, I took the synopsis that I had written, fed it into Midjourney, and it gave me this really cool kind of lithograph drawing of an old timey radio
Mm-hmm.
in front of a window that was looking out into a galaxy.
Oh, that's gorgeous.
And it was perfect. It was
Yeah,
nothing I would have
yeah.
thought of, and yet it sort of, it brought in ideas of radio stations, of being like a pirate radio station, but
Yeah.
also the sort of the time and the view and seeing the galaxy laid out in front of you as where you're transmitting the radio. And I'm
That's
like,
perfect.
it was wonderful. It was exactly what I wanted. And then I could generate 20 versions and put T-Rexes into it. So anyway, So my guess, Fraser's advice for today is don't be mediocre. There's a new competitor in town. Be
the algorithm.
excellent.
Yes.
Yeah, be excellent. Be the best. Do
I
what you
love
can.
this.
All right. Let's get on
I
with
have
this
a
week's
bone to
show.
pick for you first.
Yep.
You, sir, said Revelation Space. Read it. You did not tell me how many books it is.
4.
No, there's
With the
more than
bonus
4.
Fifth one.
Yeah, I think.
One.
Yeah. So I'm like, still going. Gonna be going for a while.
Yeah, I see. I made this horrible mistake too. So
Yeah.
apologies again to everybody. So a couple of months ago, I suggested we start this book club for my podcast, and where people go to Goodreads, they would suggest a bunch of books. I'd pick one and I read it. And so then I picked Revelation because a ton of people like, Fraser, this is it. This is your book, Revelation Space. Read it. And so like I read it. I'm like, this is the best book. You're exactly right. Oh God, it's the first one of a 4-part series with a couple of bonus books.
Yeah.
Oh God, if I enjoy this, am I going to enjoy everything that Alistair Reynolds has read? And so the horrible life lesson that I learned is that if you can't recommend a book that is the beginning of a series to me because then I'm going to want to read the whole series.
Yeah.
So
Same.
Yeah. And like, no one's got time for that. Do you have time for me to now read the entire Alistair Reynolds catalog? Because I'm in the exact same boat.
Yeah.
And
yeah.
So the next book that I choose now that I've finished the 4th book will be a standalone novel. But you're exactly right. 100%.
All right.
Well, Guido showed up. We waited for you. We held the door open. Guido.
Hodor.
Yeah, exactly.
What episode number are we on?
This is 677.
All right. We ready to do this thing?
Yep.
All right. I'm pressing the record. I'm pressing the other record. We are recording.
Okay, here we go. Astronomy Cast, episode 677. Answer is always dust. Welcome to Astronomy Cast, our weekly fact-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I have to admit, dust is one of those things that likes to get involved in every aspect of our lives. And we've avoided this show for a long time, but at a certain point, the dust catches up with you.
Is it a spring cleaning thing? Is it an allergies thing? Something put dust into our minds. Maybe it's the dust itself. Choosing the show.
It's like microplastics. It's in everything.
Yeah, as Carl Sagan said, we're made of star dust.
Are microplastics technically dust?
I don't know.
They probably
Should we
are.
just stop the show right now and dig into this? No.
No,
We'll
no.
put a pin in that. You will wait for the helpful email,
It's true. It's
which is
true.
being written right now. All right. Well, whenever astronomers discover something surprising, the answer often turns out to be dust. Dust obscuring our view. Dust changing the polarity. Dust warming things up. Dust cooling things down. It's always dust until it isn't. And we'll talk about it in a second, but it's time for a break. And we're back. So I guess before we talk about how it's always dust, what is dust in astronomically speaking?
It is molecules of stuff, and the molecular nature of it is kind of the key. And the molecules can be really, really big, like polycyclic aromatic hydrocarbons, PAHs. They can be things like methane molecules. But dust is where you start to get collections of larger and larger molecules coming together. This is where you start seeing amino acids, and eventually, as dusts get bigger, you start getting grains of ices and grains of silicates, and eventually things get big enough that we no longer refer to them as dust, but that stuff we can't generally see at a great distance.
So what would be no longer dust? Like a meteoroid?
Yeah,
A rock, a
a
pebble?
meteoroid is not a piece of dust. It's when it no longer it's when it no longer behaves in a way that is changing the qualities of the light going through it. So if you have a bunch of dust and you shine light through it, you're going to scatter out preferentially the the blue wavelengths of light. I'm going to start that sentence over,
Sure.
everyone.
Okay. Yep.
All right.
Give her.
So dust is really defined at a certain level by its behavior. If you have a cloud of dust and you shine light through it, it is going to preferentially scatter out the shorter wavelengths of light. You're going to see the blue getting sent sideways. This is how you get the really cool reflection nebulae, while the longer, redder wavelengths are able to make it through, and as the dust gets thicker and thicker, you're eventually only going to get the longest shades of infrared light coming through. But once you start getting to things that are big enough that they're just like, hi, I am solid,
Right.
it's just going to block light.
So when the moon passes in front of the sun and we
Not
get an
dust.
eclipse, that is
Yeah,
not dust.
that is
Okay.
not
All right.
dust.
Okay, so I think that sets an upper boundary. And what about a lower boundary? Like, when is it too small to be dust?
Well, so this is where you start getting at the gas-dust boundary. And so, like, if you have a cloud of carbon dioxide, carbon monoxide, you can see all of the molecular line transitions, and it is behaving like a gas. Now, once you start saying we're seeing polycyclic aromatic hydrocarbons, is that necessarily a gas? No, not really. That's a really, really big molecule. So we're starting to call things dust. And so the question becomes, exactly at what point do you say that molecule is sufficiently complicated that we're going to refer to it as dust? And this is where I think a lot of people gloss over what is the boundary between these two things by looking at, oh, that's an amino acid, that's a PAH, and by naming it instead of saying dust versus gas,
Right.
you avoid the entire problem. Once it's ionized, it's a gas.
Right. But it sounds like you did put like one pretty big constraint on it, which is that you get this bluing of the light as it's passing through it, or a reddening of the light as it's passing through it. Like, I think about smoke. Like, when we have forest fires here on the west coast of Canada, and there are times when you can see the sun with your unaided eye because it is hidden behind so much smoke.
Yeah.
Don't do it.
No.
But it's there. And so the light from the sun is not getting obscured by the moon or boulders thrown into the air, there is something that is changing the nature of the light that is coming from the sun to us.
Yeah.
And yet, the rest of the time, you've got air, nitrogen, carbon dioxide, oxygen, various atoms that are in the air in
Yeah.
between us and the sun, and they're not doing that same kind of thing. So it's this range where gas ends and rocks begin,
Yeah.
and
Yeah.
it changes the nature of the light as it passes through. Do I sort of have constraints on it?
Yes. And it starts to get ugly. There was a paper a couple of weeks ago, I think we both covered, on a newly discovered or newly understood exoplanet that is large and far, far, far away from the pair of cool stars it orbits. And so it has silicon grains in its upper atmosphere that range in size from the most diffuse smoke you've seen coming off of a candle to grains like you'd experience in a sandstorm. And so I think that way of looking at it, but then you start getting to is this grain starting to be called a rock? And yeah.
Okay. So now that we've defined dust, and like, to ask astronomers to define dust is to then begin a 2-hour argument
Yes.
where people will just describe the terminology and you may not get the answer by the end of this conversation. So just, we're not going to cover it in this podcast. But what can dust do to mess up your observations?
Everything. I think the day that I was like, oh no, it even affects me. And I think every astronomer has had this at a certain point. While working my dissertation, I was trying to estimate the distance to galaxy clusters by looking at the colors of the galaxies in the clusters, because we didn't have spectra to use yet. And I had to take into account how much the color of the galaxies gets shifted by the dust within our own galaxy. And I had to do all right, there are 5 different maps to use. This is the one that's most referenced. All right, I will use this map. And it's very unsatisfactory because people have done their best to look at a variety of objects that should all be the same color, to look in different wavelengths, to all different methods of trying to figure out how to effectively map the dust, looking for tracer species that we can see in millimeter radio light. And at a certain level, it's not like we can actually go out and measure the dust.
Mm-hmm, mm-hmm.
And we just know it's out there affecting the color that we see things. And while I can start to make estimates of how much dust is within the Milky Way, who knows how much dust is just like randomly scattered through the universe between me and the galaxy clusters I'm trying to estimate the distance to.
Right.
It gets annoying.
All right, we're going to talk about this some more, but it's time for another break. And we're back. So I guess, when I think of an analogy, like say you had like a bright searchlight that was pointed at me.
Yeah.
And then there's a fire in between.
Yeah.
And now suddenly the color of the searchlight has changed from, say, bright white to red.
Mm-hmm.
And the brightness has changed from hurting my eyes to it's not so bad.
Yeah.
And so now I can no longer be certain about what color the light was,
Right.
the searchlight was, and I can no longer be certain about how far away the searchlight is, and I can't be certain about how big the searchlight is. Like all these
things are true.
Right. So what characteristics does dust have on the observations that you try to make on some kind of object?
So, first order, it makes things redder appearing.
Right.
Second order, it makes things fainter. And which order you put those two things in really depends on what you're trying to measure. Then there's also this really annoying characteristic of light going through dust, getting scattered, will end up having a preferential polarization. This means that as the light is moving through space, you have light waves. And the way those waves are oriented is related to a whole lot of different things, one of which is, has that light been scattered off a surface like dust? And when we look at light and we see all the light has a similar way that those waves are going through space, we can say, yes, that was likely scattered by dust. And that can mask other effects, or it can be caused at a place different than where the light originated. And it can do things like confuse how we look at the cosmic microwave background, because there's a whole lot of dust between here and there.
So you're describing those first order issues. So then what are the second order outcomes of those issues?
Everything we look at, we have to be a little bit concerned that what we're understanding isn't entirely true. To go back to the cosmic microwave background, there have been various times that someone has been like, we have no, it was dust.
Right. But okay, you know what? I'm just going to hit you with a bunch of topics here, and you tell me if these are affected. The temperature of an object that we observe.
Yes.
The distance.
Yes.
The color.
Yes.
The size.
Depends.
I guess if we know, okay.
If it's angularly resolved, it doesn't change the size.
Perfect. Okay. There we go. Although,
or if it's a binary system where we have other ways, or if it's an eclipsing system, it depends.
Yep. The polarity.
Yeah.
Yes. Like, it just sounds like from those first issues, everything cascades.
Yeah.
Okay.
Yeah.
Yeah.
But dust is also cool. Well, literally, it's cold. Otherwise, it wouldn't exist. It would like fall apart. But there's things like our corona borealis stars that like will suddenly go, hi, here is dust, and fade dramatically. Right. So, I mean, like, dust does at least put on a show now and then.
Magnetic fields.
Magnetic fields are their own monster.
Right. Okay. All right. All right. So then, okay. So then how does an astronomer, knowing that it is often dust, how do they go about figuring out that if what it is that they're trying to observe is the result whole or in part by dust?
So
just like the length of you sighing, I think we could wrap the podcast up right there. And that just nailed it. But sure, no, please go on.
This is where you have to have multiple lines of evidence for a lot of things. So I think it can go both ways, though, and this is where it gets frustrating. So, like, Betelgeuse, 2019, decided it was going to not tell us that it was going to explode, but apparently forecast the coming of a pandemic, because that somehow fits with someone put that in science fiction. Anyways, so Betelgeuse back in 2019 went through this dramatic dimming, and it just kept going through the first parts of 2020. And that dramatic dimming, people were like, well, is the star doing this? Is the star doing that? And a lot of folks were like, it's dust, but it was really hard to prove that it was dust. So it can go both directions. And we just need multiple lines of evidence. If you're trying to understand the color of something, try and get its spectra, because the spectral will show you atomic lines, and the ability of an electron to jump between different levels in an atom is directly correlated to the temperature of that atom's surroundings. So if you see this line in carbon, this line in hydrogen, these 40 lines in technetium, that's going to tell you accurately what the temperature of the object is. And then you look photometrically at it's this bright in this red filter, it's this bright in this V filter. And you can start to get a sense of how what's between us and the object is affected by dust. But you have to have those multiple lines of evidence.
So back to this idea of spectroscopy, right? That you are seeing the chemical fingerprint of an object.
Yeah.
And so you observe a star, you take the spectra of the star, you see the lines for iron, for carbon, for whatever it is in the upper atmosphere of this star. If you put a schwack of dust in front of you and that star, you still see that chemical fingerprint.
Yes.
It's just redder, but the fingerprint will shine through.
Exactly.
It's dimmer, but it's still there.
You're going to see the exact same absorption lines. And what's interesting is you'll sometimes, if you're lucky, also see how the sunlight is exciting the molecules to do interesting things in the dust. And this is where we really have to look at things across the entire electromagnetic spectrum to be able to see, okay, so the dust is having this happy little vibrational and rotational set of transitions, and the star in the background is having these transitions, and allows us to actually start to put together three-dimensional temperature maps of what is happening as the light that we're seeing passes through the space from where the light originated to where we're observing it.
So, but could the dust generate its own? Could you be measuring the spectra of the dust itself and
Yes.
have a hard time to distinguish between what is the star and what is the dust?
Well, they'll have very different temperatures. A star is generally sufficiently hot that it will photoionize, to use the big words, the dust into component atoms. Dust requires cooler temperatures to exist. And so if you're seeing light that corresponds to like Lyman alpha, hot hydrogen gas, and you're also seeing, because you're using a completely different telescope, the carbon monoxide transitions, or the polycyclic aromatic hydrocarbon transitions, those are two totally different temperature regimes that cannot coexist in the same space.
Right. Okay, so you know what? We're going to take another break.
Okay.
And when we come back, we're going to talk about the times that dust messed up everything. And we're back. All right, so I think we've defined our dust.
Yes.
We've explained how it messes things up. So how did dust confuse astronomers on various discoveries?
My favorite three examples, I've already brought up Betelgeuse.
Yep.
The other one is, I'm going to mispronounce this, and I apologize so much. It's Boyajian's star, or Tabby's star.
Yeah.
And then of course there's our Corona Borealis stars. Observationally, our Corona Borealis was the first one to be discovered. It was found in the 1700s. These are a class of star for which only a dozenish examples are known, and they will be going along with fairly normal periodicities of changes in brightness, and then will suddenly go poof and disappear as they fade by as much as 9 magnitudes.
Wow.
Yeah, they're wild. And it's thought that what happened is two lower mass white dwarf stars coalesced, formed a new orange giant star, and are just periodically shedding loads of dust. And so that's a case of, it took a few hundred years to figure out what was going on, and we're now pretty sure that these massive drops in brightness are just dust coalescing, and that's just really cool.
But I mean, I can think back to, like, there was this map of the Milky Way that, was it Herschel created, I think, like hundreds of years ago, that Herschel was trying to map out the positions and distances to the various stars in the sky, and built this map that, surprise, surprise, had the sun at the center of the universe.
Because of dust.
Yeah. That he just wasn't able to observe the more distant objects. And so you got this blob that made him feel like, you know, he was literally drawing out the shape of the Milky Way as this, I don't know.
Well, so what he did,
pot roast.
what he did was he counted the stars in each direction
Yeah.
and assumed that the density of stars on the sky related to how much Milky Way was in each direction. And when he looked towards Sagittarius and when he looked counter to Sagittarius, there were in optical light similarly ginormous numbers of stars. The distribution towards Sagittarius was bigger because we have the bulge in that direction, but he didn't know that at the time.
Yeah.
And so by just counting the surface density of stars without having modern telescopic equipment and not being able to see in colors your eyeballs don't see in, yeah, we were at the center of things. And the first time we really realized we weren't at the center was, I'm trying to remember who it was. I want to say Oosterhoff, but I don't think it was Oosterhoff. It was in the 1900s where they started looking at the distribution of globular clusters. And since globular clusters are in the halo of the galaxy, they have a spherical distribution, and you can start to see that we aren't in the center by looking at globular clusters. But
Right.
it was a modern discovery because dust.
Right. Right. Can you give another example? I mean, I can throw a few more that I'm aware of, but you talked about Betelgeuse, you talked about Voyager Star, but
Yeah.
like, but then that much earlier example, there was a fairly recent, I don't know if people remember Dr. Brian Keating and the team with the Bicep 2 observations, where they
Yeah.
thought they'd observed primordial gravitational waves in the polarity of the cosmic microwave background radiation. Turns out it was dust.
Yeah. Yeah.
Nobel Prize
gone.
lost. Yeah.
Yeah.
So are there some other examples that where dust has obscured the results and it took a while for people to figure it out?
I think there's just been a whole lot of stars over the years where we've been trying to understand what's going on, and dust just left us a little bit foiled. And I have to admit that there are so many examples of dust foiling people that I have chosen to mostly look at where dust was our friend. So, for instance, we were able to start figuring out how stars form by looking in millimeter wavelengths of light for these cocoons of dust where stellar proplyds were located. And I'm a bit taken aback that we went with this biological language to describe it. But yeah, so dust is the cocoon that hides where stars and solar systems are forming. And when we look out with the Atacama Large Millimeter Array at these systems, what we're seeing is protoplanetary disks in a lot of cases that are constructed out of dust, with occasionally planets making their way through the dust, creating amazing eddies and dust lanes. And so dust does have a purpose.
I mean, it definitely has a purpose, but I also think, thanks to modern infrared astronomy, astronomers have a way to see through the dust.
It's true that we went from the collection of Bach globules, these cold giant molecular clouds, and again, at a certain point, giant molecules become dust, and giant molecular clouds are rich in dust.
Right.
And so these globules went from being these really cool for astrophotography dark places on the sky to being things that we're like, let's go look through this with a different wavelength of light. And it's convenient to have other wavelengths of light to look at things.
That's cool. I mean, I think about, say, our ability now, like with the new images that are coming from JWST, that they're able to peer into these newly forming solar systems and see the planets.
Yeah.
There was like an observation that came out a few months ago where they were able to directly observe the atmosphere of an exoplanet that's only just a couple of million years old.
Yeah.
The ability to see through the zone of avoidance, the gas and dust that obscures the center of the Milky Way, to see what's on the other side.
And it starts to let us go in the opposite direction as well. For decades, we understood that there was this gravitational thing that we named the Great Attractor that
Right.
galaxies appeared to be moving towards, and we couldn't see it because dust. And yeah, these longer wavelengths let us get through the dust and identify what is shaping the motions and shaping the formations. And dust basically blocks our view, conducts how everything should move, and is luckily susceptible to millimeter wavelength radiation.
Right. Yeah, I mean, I always find that hilarious when people are like, "Can you explain the Great Attractor?" I'm like, "Yes."
Yeah.
I mean, it has now been mapped.
It took a while.
Took a while, but now we know the locations of all the galaxies, and the mass of those galaxies explains the weird movement of everything sliding towards it. Done. Problem solved.
Yeah.
So are there any outstanding mysteries in astronomy where dust continues to make things more difficult?
Well, I mean, there's always going to be people who are like, the reason that type 1A supernova, not type 1A, type 2A supernova look the way they do is because there's dust. There's always going to be people, basically any cool discovery, saying it's not actually a cool discovery because dust.
Right.
And it just gets exhausting.
Yeah. I mean, is it really that first instinct to astronomers to go, could this be dust? Do you think that's like high up on their, I don't know, science nervous system?
So there's curmudgeons in every group. And if you find something really, really cool, there's going to be the curmudgeon who's trying to disprove that you actually found something cool. And dust is going to be first on their mind because sometimes they're right. And this, like, we didn't actually explain what Tabby star is at all. It's this system that was observed to have remarkable dips of 20% of its brightness over periods of days. And it was very strange, the pattern of increasing and decreasing. And folks were able to go back through the historic record and find long-term dimming. And for a while, people were like, have we found the beginnings of a Dyson sphere being built?
Right.
And there was, I think, in all of this little tiny, tiny hope, tiny, microscopic, too small to be called dust hope, that maybe it was a Dyson ring, Dyson
I'm
sphere.
not saying it's aliens,
Dyson
but I'm
swarm.
hoping it's aliens.
That.
Right.
And no, that was dust. It was dust.
Once again. All right. Well, thank you, Pamela. So just remember, like literally any interesting discovery that you ever make from this point on, any ailment that you experience, just ask yourself, could this be dust?
The answer is probably yes.
Probably. All right. Thanks, Pamela.
Thank you. And thank you to all of our patrons out there who get ad-free versions of this show through patreon.com/astronomycast. This week, we'd like to thank in particular Roland Vormerdam, Jeff Collins, Kellyanne and David Parker, Jeremy Kerwin, Stuart Mills, Harold Bardenhagen, Scott Bieber, Kimberly Rake, Marco Iarasi, Matthew Horstman, Alex Cohen, Georgie Ivanov, Daniel Loosely, DFM, David Gates, Kinsaya Pintelenko, Jim Schooler, Disastrina, Scott Cohn, Claudia Mastriani, Justin Proctor, Matthias Hayden, Gregory Singleton, Jeff Wilson, Cooper, Tim Garish, and Tim McMacken. Thanks, all of you, for allowing us to do everything we do. Thank you.
And we'll see you next week.
Bye-bye. And then they saved. Okay, that's the correct folder.
677.
Have you gotten your shingles vaccine yet?
No, and I will.
Yeah, so I recorded last week, and I had a rash that I thought was poison ivy. I blamed the dog. And I had a couple of different people go, "Are you sure it's not shingles?" Totally shingles. Shingles. Yeah.
Oh, I've had a couple of friends who've had just been debilitated by shingles.
life doesn't let me give in to illness. So I have been fighting through, and it's just sort of
Oh,
like,
okay. Thank you for
get
the reminder. Yeah.
get your
If you're,
vaccine.
yeah, I think it's like over 45, go get your shingles vaccine.
Yeah, so in the US they generally recommend 50,
Hmm.
but what I ran into, so it was the stupidest situation. Healthcare in my country needs help. So after realizing it was probably shingles, there's a 17-hour window during which you can still go get antivirals. After 72 hours, they don't let you get them.
Hmm.
And it was after hours, urgent care was closed, doctor's offices closed, and so I like had different humans going, get thee to the ER right now, and I get to the ER and there's an 8-hour wait.
Yeah.
And so that would have put me outside of the 72-hour window. But I have a credit card. So I sat in the waiting room of the ER and found a way to do telehealth at midnight and get a prescription.
Wow.
So
So do you think, when did you take the antivirals?
I was like right at 72 hours.
And
So
how long ago did you take them?
I started taking them Tuesday morning.
So you're about, like almost a week into it.
Yeah, yeah.
Huh.
So, yeah.
Yeah.
But the doctor I talked to, he's like, yeah, I'm getting lots of young people with shingles. It turns out that the human body was not designed for the dumpster planet of the modern news cycle.
Right.
And so lots and lots of people, he said, are getting shingles at below the age that they recommend the vaccine. So
Hmm.
he was recommending the vaccine to anybody.
Yeah. So my kids got the chickenpox vaccine.
Yeah.
So neither of them have had chickenpox,
So they can't get shingles.
and they can't get shingles.
Yeah.
Yeah.
That's a thing.
Yeah. So if you have kids, get the chickenpox get them the chickenpox vaccine. Like I think people feel like chickenpox is like a rite of passage.
No.
You can see on my head my chickenpox scars. And everybody, it's weird. You like watch
Yeah.
TV and you're like, oh, chickenpox scar, chickenpox.
Yeah.
Like,
Yeah.
everyone's got them. And
The Zoomers
and
don't.
oh, maybe. And I guess if they've been able to take the vaccine, but I
Yeah.
don't know of any other parents that had their kids get that vaccine. I
Really?
mean, yeah, I mean, there's a great set. I mean, there's the HPV vaccine, which
Yeah.
our kids had. There's the chickenpox one. There's there's some other even more kind of obscure ones. Is it mono?
And even young boys should
Yeah,
get HPV
totally.
because, like,
Takes two
not
to
only
tango.
can they be carriers, but there have been cases of other forms of cancer
Yeah.
that folks have gotten from HPV. That virus can cause cancer in other parts of your body.
There are theories out there that many cancers are caused by viruses.
Yeah, yeah.
Not just like we're seeing examples that we know, but then there's a whole bunch of other ones. So,
Yeah.
yeah, boy, like what a simple solution is to get vaccinated.
Yeah.
It's so scary. So anyway, does anyone have any questions?
I should open up Twitch.
Hal McKinney asks, is dust dense enough to propagate a wave?
Yes. Well, it
Yes.
can be, not always.
Right. So if you had like a shock wave moving, because there's some great pictures, we get the shock wave moving through dust, and it compresses and heats up, and then puts out radiation, and then the radiation puts light pressure on other dust.
Yeah.
So it's more complicated than that. But I want, yeah. But yeah.
So Kangaroo Steve asks, do you have to take into account the increase and decrease in volcanic activity and pollution, or is that mathed out with computers? No, you totally have to, for some things, take that into account. And there is the funniest paper in retrospect that came out of the University of Toledo Observatory where they thought they had found, I forget which really large molecule it was, in stars, and it turned out it was the guy smoking a cigar in the dome while taking
Oh,
spectra, and his cigar smoke caused absorption lines. And
oops.
they figured it out in part because the lines were at the redshift of the observatory and not the star.
Yeah. Oh, that's funny. There's also oh, so there's dust in the solar system, and
Yeah.
so one of the things that New Horizons has done is taken images of the amount of dust in the solar system
Yeah.
from beyond the dust, be able to look out into the Milky Way, and in some cases measuring the infrared background radiation, it's been able to make a vastly more precise measurement
Yeah.
of the amount of of background infrared radiation than can be made from here. And so there's like, for almost every reason, it's fine to put a telescope in Earth orbit or put it at the L2
Yeah.
Lagrange point. But there are some observations that it actually does make sense to send your telescope up to Pluto and take your pictures there.
Yeah. And there's been research looking for the detailed effects of the Oort cloud on observations.
Yeah.
It's thought that we might be able to eventually detect the Oort cloud through how it causes low level polarization in background light. Yeah.
Hmm. Amazing. All right. Well, we've actually reached the end of our show. I guess we put our rant up front. I'm gonna go back and continue wrestling the monster that is ChatGPT 4 to make
Yep.
it behave.
Excellent.
What are you working on?
Um, I am working on. I still have to write our script for Escape Velocity Space News for this week because I decided to
Script.
get shingles.
Scripts.
You know me. I don't remember facts the way you do.
Well,
This man can remember numbers in a way I can only dream of being able to do.
Carla was giving me a hard time about that. And she's like, "You've got a really good memory." I'm like, "No, I don't." And she
Yeah,
goes,
you
"Whoa, whoa,
do.
whoa. You remember all this detailed stuff. Like you remember
Yeah.
the words to a song." It's fun. What was that? I was humming Moana from,
From Disney,
I was
yeah.
singing, yeah, I was singing the song, with Maui. And she was
Uh-huh.
like, "How many times have you seen Moana?" I'm like, "I don't know, once." She goes, "Wait, you remember the words to the song that you heard once?" Like, guess. Um, but then other stuff slips through my brain, and I have trouble remembering it, and I have trouble accessing it. All of us,
Yeah.
right? But
We each
yeah,
have different things. I'm really good at remembering like concepts that affect three-dimensional motion and
mhm,
thinking kinematically and
yeah,
basic physics concepts. It's like my brain is like, this is my thing. The
yeah,
numbers you remember, the names you remember, nope,
yeah,
not
yeah,
me.
yeah, for sure. It's a funny thing, and so like I double down on it. Like I use
Yeah.
Anki to double down on it because it's useful to. But for my process, like I used to write scripts,
Yeah.
and my new process, like when I do my Space Bites show, is I sit down for about an hour and I just rough out the notes of what I'm going to talk about.
Yeah.
And then I kind of don't have to look at my notes because by the creation of the notes, it's in my head for 1 hour.
Yeah.
Right. And so that I can do the video and then it's gone.
Yeah.
And so that is the appropriate way to prepare for that length of a thing is I need to organize my thoughts, but I don't need to come up with the individual words because I know I'll just freestyle.
Yeah. So we do usually about 10 stories, and
Yeah.
that is about 8 stories more than I can store in my brain.
Yeah, so I do about 10. I do about 10 as well. But it's the preparation that puts it into like short-term memory
Yeah.
just long enough for me to complete the episode. So,
Yes.
like an hour before we shoot, I will make my notes for all the stories that we're going to cover today. And that sort of describes I've thought through my approach vector on each one of these stories,
Mm-hmm.
and I've laid down what I think are some interesting facts into it, and then we'll record the show, and then I can feel it just leaving my brain like a like a ghost, and then it's gone.
Yeah.
It's this ephemeral thing. but it saves me the time, and I think it gives me a more natural style
I
than
can
something that I'm reading.
remember the science, and if I was only discussing the science, I could do that.
Yeah.
But like, I want to give credit to the scientists, and I will not remember their names.
Yeah.
And so it's just stuff like that. Your brain is better than mine at proper nouns. Let's just go with that. You are better at
Right.
proper nouns.
But I think, like, again, to your credit, like, there is no script for
No, we do,
Astronomy Cast.
and we very rarely have proper nouns.
Right. True. But also you do a great job of replying to anything that I will ask.
Yeah.
Right? Like,
Yeah.
your knowledge about the underlying fundamentals is so broad that you can instantiate an explanation in real time when you don't necessarily know where we're going to go.
Yes,
Right?
that is my
that's
superpower.
just amazing. Yeah, that's just amazing.
So we have complementary superpowers. If we had the same one, we couldn't do this show, but we have complementary ones.
And I think the value that I bring to this process is that we've spent enough time now that I'm running a simulation of Pamela in my brain that allows me to navigate along paths that showcase your strengths and allow you to duck the weaknesses. We're not going to drive into that sand pit. I'm not trying to gotcha you. I'm trying to make you seem like a genius as much as possible, and not, Pamela, I want you to recall the 10 names of physicists who, that's just gonna suck. So anyway, it's a fun process, and I think taking this, the longer we do this, the better we get.
It's very true.
The more accurate the simulation of our brain of the other of the other person becomes, and the more I can ask you questions that bring value to the listener.
Yeah. And you nailed it today. I was like walking down the stairs and I'm like, I do not remember the name of the experiment that Dust foiled that was part of looking at the CMB, but Fraser will know. I literally had that thought coming down the stairs. That's and awesome. Sure enough, you brought up the exact name and we were good. Yep.
All right. Well, we've reached the end of our show. Thank you, everyone, for hanging out with us today. Do you notice there's new colors in YouTube? I guess you're not looking at YouTube. There's new colors in YouTube. I don't understand what they mean.
I saw
some are blue, some are orange, some are red.
Yeah, I haven't figured all of it out. And then Discord offered up a whole bunch of new colors if you're using Nitro. I feel like everyone decided to add color for spring.
Like you just get a color. So Lulu Girl, you are kind of teal. John Suffley, you're blue, but I guess because you're a moderator.
Yeah.
Nadia is also that teal color, but Corvair Wind is orange. Kent Score is red. Kim Barron is pink.
I wonder if people can set their individual colors like they can in Twitch. That would make sense. Or does it have
something to do with whether you're a subscriber or not? I don't know what this means.
Yeah, I will poke at it later.
Yeah, okay. All right. Well, thank you, everyone. Thanks, Pamela, and we'll see you next week.
Bye-bye. And, this is where I realized I hid the window from myself. Okay, awkward transitions. Ahoy. Awkward.